System information. Asterisk 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 notice asterisk asterisk asterisk. This manual documents the TMP 4100, the TMP 4100E, and the TMP 4150 marking heads. The TMP 4100 and TMP 4150 heads contain a pneumatic pin that uses air pressure to drive the pin from and return the pin to the pin cartridge. The TMP 4100E uses no air pressure. The TMP 4100E electric uses electric solenoid to drive the pin and an internal spring to assist pin return. Operation of the marking heads is almost identical. Where variation do exist, they will be clearly identified within the text to inform you of the differences. 1.1 Use of machine. The telesis TMP 4100 series/400 marking systems permanently print text messages into a variety of materials such as steel, aluminum, and plastic. Marking is accomplished as a hardened pin indents a message of dot matrix characters into the item being marked. The marking head pin cartridge moves through the required X-axis and Y-axis motions to reach the correct position for each dot. The marker fires the pin so that it strikes the surface area the instant the cartridge is in its programmed position for the character to be marked. The shape and location of marked characters are determined by system software. 1.1.1 Intended usage. TMP 4100, TMP 4100E. The systems are designed to address a wide variety of marking needs. The TMP 4100 and TMP 4100E markers are handheld markers. They may be used in any orientation except inverted, that is, with the handle pointing upward. A key factor in their design was weight and size. Accordingly, they weigh approximately 5 pounds, 2.25 kilograms, with the cover and handle installed. Their lightweight and comfortable grip, coupled with their compact shape, makes them an excellent choice for hand-held marking applications. TMP 4150. The TMP 4150 is a fixture-mounted marker for inline use. The marking head may be mounted in any orientation except inverted, that is, with the mounting holes pointing upward. Typically, it should be mounted on a tooling fixture with the pin pointing downward. The TMP 4150 marking head employs a protective boot to help prevent contaminants from entering the marking head cavity. Other configurations or usage must first be evaluated before approval can be obtained. Please consult telesis customer support. Support for more information. System information. 1 to 2. 1.1.2 Modes of operation. The marker may be operated in 2 modes, operator and supervisor. Access to the supervisor mode may be password protected to restrict usage by unauthorized personnel. Operator allows you to select patterns, enter messages and mark components. Refer to Chapter 3 details on the operator functions. Supervisor allows you to perform all tasks available to the operator. Plus allows you to design patterns, change system operating parameters, and check system performance. Refer to Chapter 4 for details on the supervisor functions. Before operating the system, read Chapter 2 for general operating procedures and complete instructions on starting the system. 1.2 Description of equipment. A basic, standard system is illustrated in Figure 1:1. Figure 1:1. TMP 4100 series/400 marking system diagram. TMP 4100 series/400 operation. 1 to 3. Change 1. 1.2.3 Marking head. The marking head includes the mechanical motion components to position the marking pin. The cartridge is attached with screws rather than clasps, contributing to reduced weight, compactness, and portability. TMP 4100, TMP 4150. The TMP 4100 and TMP 4150 contain the pneumatic components to fire the marking pin. The drive air for both markers is controlled externally by a regulator on its filter/regulator unit. The TMP 4100 uses an internal regulator to control the return air pressure. The return air for the TMP4150 can be adjusted externally by a separate regulator on its filter/regulator unit. TMP4100E. The TMP4100E uses an electric solenoid to fire the pin. A spring returns the pin to the cartridge. The various marking head have the following physical characteristics. TMP4100. Weight 4.08 lb. 1.85 kg. Marking head with handle 5.50 lb. 2.49 kg. Marking head with handle and marker cable. Dimensions LXWX 9.19x 4.55x 7.93 in. 234x 116x 201 mm with 25XL pin and handle. 9.44x 4.55x 7.93 in. 240x 116x 201 mm with 150s pin and handle. X-axis travel 2.0 in. 50.8 mm maximum. Y-axis travel 0.3 in. 7.6 mm maximum. Number of impact pins 1. Pin type 25XL- or 150S series. Pin material powered metal or carbide 25XL series. Powered metal or carbide tip 150S series. Pin stroke 25XL series pin 0.125 in. 3.1 mm recommended. 0.5 in. 12.7 mm maximum. 150S series pin 0.125 in. 3.1 mm recommended. 0.25 in. 6.4 mm maximum. TMP4100E. Weight 4.08 lb. 1.85 kg. Marking head with handle 5.50 lb. 2.49 kg. Marking head with handle and marker cable. Dimensions LXWX 9.91x 4.55x 7.93 in. 252x 116x 201 mm with 25XL pin and handle. X-axis travel 2.0 in. 50.8 mm maximum. Y-axis travel 0.3 in. 7.6 mm maximum. Number of impact pins 1. Pin type 25XL. Pin material carbide. Pin stroke 0.187 in. 4.7 mm maximum. System information 1 to 4 change 1. TMP4150. Weight 8.7 lb. 3.9 kg. Marking head, brackets, and cable. Dimensions LXWX 9.89x 5.12x 4.96 in. 251x 130x 126 mm with 25XL pin/O-boot asterisk. 10.14x 5.12x 4.96 in. 258x 130x 126 mm with 150s pin/O-boot asterisk. Asterisk boot dimension 5.33 in. 135 mm diameter. NEMA rating 12 IP55. X-axis travel 2.0 in. 50.8 mm maximum. Y-axis travel 0.3 in. 7.6 mm maximum. Number of impact pins 1. Pin type 25XL- or 150S series. Pin material powered metal or carbide 25XL series. Powered metal or carbide tip 150S series. Pin stroke 25XL series pin 0.125 in. 3.1 mm recommended. 0.5 in. 12.7 mm maximum. 150S series pin 0.125 in. 3.1 mm recommended. 0.25 in. 6.4 mm maximum. 1.2.2 filter/regulator unit TMP4100. The filter/regulator unit includes a regulator with a coarse filter and a pressure gauge to control the drive air. The unit also includes a coalescing filter to remove finer particles. The drive air fires the pin from the cartridge. TMP4150. The filter/regulator unit includes two regulators with pressure gauges to control the drive air and return air. The first regulator contains a coarse filter. The unit also includes a coalescing filter to remove finer particles. The drive air fires the pin from the cartridge. The return air pushes the pin back into the cartridge. TMP4100E. The TMP4100E does not employ a filter/regulator unit. It uses electric solenoid to drive the pin and an internal spring to assist pin return. TMP4100 series/400 operation 1 to 5. 1.2.3 controller. The controller runs the system software and generates commands to control the marking head. The controller contains an integrated keyboard with a 4-line liquid crystal display LCD. It provides the user interface to the marking system, allowing the operator to select commands and make choices displayed by the system software. Function keys on the keyboard are assigned special features for marker operation. The back panel of the controller includes a marker port for connection to the marking head, a host port for connection to RS-232 or RS-485 devices, such as a host computer or barcode scanner, an I/O port for connection to a logic controller, such as a PLC or relay-generated input/output signals, and a TTL-I/O port for use with telesis supplied options such a remote push-button station. 1.2.4 System Software. The system software is permanently installed in the controller. It produces the user interface screens that are displayed to the operator. It uses operator-supplied input and its internal commands to control the marker. The software also contains a library for storing user-defined messages. The messages, called patterns, may contain many individual text strings. The text strings, called fields, define the characteristics, content, and location of the data to be printed. 1.2.5 Support Materials. Additional information about the TMP 4100 series/400 marking systems may be found in the following publications: TMP 4100 series/400 Installation Manual, TMP 4100 series/400 Maintenance Manual, Backup 400 Software, Additional Servicing, Repair, and Overhaul information is provided in the TMP 4100 Series Service Manual and the TMEC 400 Service Manual. These service manuals, however, are only made available to repair agencies trained and authorized by Telesis Technologies, Inc. Optional software utilities to back up marking system patterns from the TMEC 400 controller to your personal computer. Please contact Telesis customer support for more information. System information 1 to 6. 1.3 Normal operating conditions. The following paragraphs outline the normal operating parameters for the marking head, the filter/regulator unit, and the controller. 1.3.1 Marking head. TMP 4100. Temperature 32 degrees to 105 degrees Fahrenheit, 0 degree to 40 degrees Celsius. Humidity 0% to 80%. TMP 4100E. Temperature 32 degrees to 105 degrees Fahrenheit, 0 degree to 40 degrees Celsius. Humidity 0% to 80%. TMP 4150. Temperature 32 degrees to 105 degrees Fahrenheit, 0 degree to 40 degrees Celsius. Humidity 0% to 80%. 1.3.2 Filter/regulator unit. TMP 4100. TMP 4150. Temperature 32 degrees to 125 degrees Fahrenheit, 0 degree to 52 degrees Celsius. Operating pressure 120 psi 8.3 bars. Maximum 1.3.3 Controller. Temperature 32 degrees to 105 degrees Fahrenheit, 0 degree to 40 degrees Celsius. Humidity 0% to 80%. Shock 30/4 millisecond half sine wave operating. 75/11 millisecond half sine wave non-operating. Vibration 0.67 G5-500 Hz. Random RMS operating. 1.04 G2-200 Hz. Random RMS non-operating. TMP 4100 series/400 operation 2 to 1. Chapter 2. Operation Overview. This chapter describes marking terminology, concepts and general operating procedures for the TMP 4100- series/400 marking systems. You should read this chapter and understand this material before operating the marker. 2.1 Marking terminology and concepts. This section discusses the marking area window and how you can design patterns to mark within it. It explains patterns and fields and how they are used to mark your messages. It also provides an overview of character fonts, which includes illustrated examples and some guidelines for their usage. 2.1.1 The marking window. The marking window is the rectangular area where messages may be printed by the marker. The size of the marking window is 50.8 mm 2.00 in wide and 7.6 mm 0.3 in high. If you attempt to print any part of the message outside of the marking window, the system will issue a message alerting you to the problem so that it may be corrected. 2.1.2 Patterns and fields. The system allows you to design messages for printing by defining patterns. Each pattern describes the content of its message and how it will be printed. A pattern may contain many fields. Each field describes a single text string that may include alphanumeric characters, symbols, and special message flags. The message flags automatically insert data into the text string, such as serial numbers, times, and dates. The pattern contains all the information the marker needs to print your message. It not only defines the content of the message, but it also describes the printing characteristics, text font, character size and spacing, printing method, etc., and where each field is to be printed within the marking window. Each pattern definition is saved in the controller's permanent memory. Patterns may then be loaded for use whenever needed. You can design patterns for marking specific parts or define several patterns to mark different messages on the same type of part. This diversity allows you to tailor your messages without redefining your patterns each time they need to be printed, resulting in virtually unlimited control of your marking needs. Operation Overview. 2-2. 2.1.3 Font Styles. The system can print messages using several character fonts. The character's font determines its printed appearance. Fonts are selected when the supervisor defines the message parameters. The font selections are illustrated and described below. For a complete list of the standard font selections and their character sets, refer to Appendix A of this manual. Note: the samples in the illustration have not been scaled, so that you can more easily see the variations in their design. Figure 2-1. Font selections. As you can see, the selected character font will provide a different appearance for the marked message. The characters not only comprise a different number of dots pixels, but the character shapes are also different. Table 2-1. Font descriptions. Font type description. 5x7 creates characters 5 pixels wide and 7 pixels high when printed in dot matrix mode. This is the standard font used in most marking applications. OCR creates characters 5 pixels wide and 9 pixels high when printed in dot matrix mode. This font can be read by the telesis PS OCR registered sign optical character reader. The OCR font contains a limited number of characters, numbers 0 to 9, uppercase letters AZ, and 2 special characters, the period and the dash. There are no lowercase letters in this font selection. 11x16 creates characters 11 pixels wide and 16 pixels high when printed in dot matrix mode. User custom font created by and downloaded from Telesis logo/font generator designer software. Please contact Telesis customer support for more information. TMP 4100 series/400 operation. 2-3. Font considerations. Some factors you may want to consider when selecting a font are the size of the characters to be printed and any special requirements you may have for printing speed, character identification, or character recognition. Size. The size of the characters to be marked will influence your font selection. For example, very small characters may have a better appearance with a font containing fewer pixels. On the other hand, very large characters will benefit from higher pixel densities. Characters with a higher pixel density also allow for more delicate shapes. Speed. Your required marking speed is also a consideration when selecting a font. Characters with higher pixel densities may require a longer marking time. You may wish to mark samples with different fonts before deciding on the font for your particular needs. Character recognition. The OCR font is a special font designed to be used with the Telesis PS OCR registered sign optical character reader. In order for the characters to be reliably read by the PS OCR registered sign, a special relationship should exist between the character height, width, and pitch. Note: a fixture-mounted TMP 4150 marker may be used to mark characters that will be read by the PS OCR registered sign. This will help produce a consistent, quality mark required by the PS OCR registered sign for reliable reading. To achieve this, follow these guidelines for setting the text dimensions when you design a message to be used with the PS OCR registered sign. 1. Decide the height of the characters you want to print. The height parameter will be used as the basis for establishing the width and pitch parameters. 2. Set the width equal to 1/2 the height. 3. Set the pitch equal to the height. These parameter settings will provide a square character block height x pitch, with the actual character occupying the first half of the character block. This relationship will provide a character height/width ratio that permits the PS OCR registered sign to recognize the characters, and enough space between characters for the PS OCR registered sign to provide reliable readings. For example, if you want the characters to 0.20 inch high diamond suit, set the width to 0.10 inch diamond suit, set the pitch to 0.20 inch. The resulting height-width-pitch relationship will be sufficient to work with the PS OCR registered sign. Operation Overview. 2-4. 2.1.4 Printing modes. The text of your message may be printed in continuous or dot matrix mode. Continuous mode allows you to specify the print density to produce fully formed characters giving an engraved appearance. Dot matrix mode marks the characters as a pattern of dots as defined by the selected font style. Using continuous mode may slightly increase pin wear and may significantly increase the marking cycle time. 2.1.5 Marking considerations. There is no singular equation to follow to produce a particular mark. The quality of the mark is dependent on many factors: pin type, pin stroke, marking depth, material hardness, material finish, and, where applicable, drive air pressure. Usually, it's best to experiment with different combinations of these factors to obtain the best mark for your application. Pin types. The marker may use a variety of impact pins. Pins differ in size, length, material, and cone tip, angle, size. All other variables being equal: material hardness, finish, operating parameters, etc. Larger pin sizes apply higher impact pressures to the part being marked, resulting in larger dot diameters and greater depths of mark. Material. Powdered metal pins are good for marking relatively soft materials such as mild steel, aluminum, copper, and brass. Carbide or carbide tip pins are good for marking harder Rockwell 30C 40C materials. Carbide pins will produce a slightly deeper mark than powdered metal pins. However, since they are heavier pins, they mark at a slower rate, so marking time may increase when carbide pins are used. Cone angle. The cone angle is the angle at the tip of the pin. Smaller cone angles 22 degrees create shallower dots that are larger in diameter. Conversely, larger cone angles 60 degrees create deeper dots that are smaller in diameter. Larger cone angles, when used to mark very soft materials, may require you to slow the marker down to prevent the pin from dragging hanging up in the soft material while marking. TMP 4100 series/400 operation, 2 to 5. Marking depths. The force required to imprint a dot is instantaneous and the dot is concentrated in a small area. This minimizes the total force impacting the part being marked. Major variables affecting the depth of mark are pin, stroke and drive air pressure. Note: TMP 4100E. The TMP 4100E does not use air pressure to drive the marking pin. Drive air pressure is a factor for pneumatic units only. Pin stroke. Pin stroke is the distance the pin travels prior to contacting the part being marked. The pin accelerates through its entire range of travel, achieving maximum speed at its maximum stroke. Varying the pin stroke can be used to increase or decrease the pin depth, penetration and the dot diameter. Therefore, as the pin stroke is increased, the depth of mark and the pixel dot diameter also increase. Drive air pressure. Varying the drive air pressure can be used to increase or decrease the pin depth, penetration and the dot diameter. Obviously, the depth increases as drive air pressure increases. However, adjusting drive air has less effect on marking depth than changing the pin stroke. Marking surfaces. The pin you choose must be able to penetrate the marking surface deep enough to achieve a dot diameter that contrasts with the surface finish. In order to obtain a good contrast, you must consider the material hardness and finish, as well as the pin cone angle, the pin stroke and, where applicable, the drive air pressure. Hardness. Material hardness influences the pin size and cone angle needed to achieve a quality mark. Additionally, any external influences on the part that may inhibit marking, such as oil, machining fluids, humidity, dust, dirt, wax, paint, scale or rust, must be taken into account. Finish. The surface finish of a material is probably the most important consideration in pin selection. Even on very hard material Rockwell 40C, the marking system can use a small pin to obtain a very legible mark at 0.001 inch, 0.0025 millimeter depths if the material has a smooth as glass finish. As a general rule, try to choose a pin that produces a dot diameter large enough to contrast with the surrounding finish. Operation overview, 2 to 6. 2.2 Operation Basics. This section describes the marking system controls, outlines the equipment setup, and provides an overview of the operating sequence. 2.2.1 Description of controls. Controller. The controller contains an integrated keyboard with a 4-line liquid crystal display LCD. It provides the user interface to the marking system, allowing the operator to select commands and make choices displayed by the system software. The controller uses input commands from the operator, through the system software, to control the marker. Function keys on the keyboard are assigned special features for marker operation. The system power on/off switch is located on the back panel of the controller. TMP 4100. TMP 4150, drive air pressure control knob. The filter/regulator unit provides a gauge and a control knob to adjust the drive air pressure. The drive air fires the pin from the pin cartridge. TMP 4150, return air pressure control knob. The filter/regulator unit provides a gauge and a control knob to adjust the return air pressure. The return air pushes the pin back into the pin cartridge. TMP 4100. TMP 4100E, start print button. The handle on these handheld units incorporates a push-button trigger to initiate a print cycle. The software allows the switch to be configured for press and release or press and hold. Check with your supervisor to determine your system's configuration. If configured as press and hold, the system will abort the print cycle if the button is released while printing. Reset the marker to the pattern part position, and keep the marker online. 2.2.2 Equipment setup before operating the marking system. Ensure the controls and switches are set as follows. 1. Controller on/off switch, set to on. 2. TMP 4100. TMP 4150, drive air pressure, set between 70 and 120 psi 4.8 to 8.2 bars, nominally 90 psi 6.2 bars. 3. TMP 4150, return air pressure, set between 15 and 30 psi 1.0 to 2.0 bars, nominally 20 psi 1.4 bars. Note, refer to Chapter 5 for instructions on setting the air pressures. 2.2.3 Sequence of operation. Typically, The marker is operated in the following sequence. Optionally, the system and system software may remain on, from shift to shift so that unnecessary power-up and start-up procedures may be avoided. Diamond suit turn the system's electrical equipment on. Diamond suit TMP 4100. TMP 4150 turn on or adjust the system's drive air pressure. Diamond suit TMP 4150 adjust the system's return air pressure. Diamond suit load the pattern to be printed. Diamond suit position the part to be marked. Diamond suit mark the part. Diamond suit remove the marked part. Diamond suit repeat the printing process for all parts to be marked, loading new patterns when appropriate. TMP 4100 series/400 operation 2 to 7. 2.2.4 part orientation. Whether using the marker as a hand-held unit or with the marking head mounted on a tooling fixture, it's important to understand the placement of the marking head relative to the part to be marked. Patterns are designed to mark objects at precise locations within the marking window. If the part is incorrectly positioned relative to the marking window, the marker may not produce the results you expect. The upper left corner of the marking window serves as the 00 reference for the pattern. The location of objects in the pattern are defined by X and Y coordinates relative to the 00 origin. Since the marker uses this reference point to locate and print the objects, and since all objects must reside within the marking window, you can see that proper alignment of the part within the window is critical to obtaining a satisfactory mark. In addition to the marking window orientation, the distance between the marker and the part is also critical. The distance between the retracted marking pin and the marking surface is known as the pin stroke. It is the distance the pin travels before contacting the part being marked. Pin stroke is a major factor in determining the depth of the mark. 2.2.5 Marker movements as an operator of the marking system. It's important to understand the movement of the marking head during the marking operation. Home position. The marking head's home position is at /y coordinates 0.00, 0.15 left. Middle point of marking window. The marking head will move to the home position when the machine is placed online. It may also be programmed to move home when the system starts or finishes printing a pattern. The home position is preset at the factory and cannot be changed. Part position. When the system finishes printing a pattern, the marking head will move to its part position. Unlike the home position, the part position can be defined by the pattern designer and the part location may be different for each pattern. For fixture-mounted TMP 4150 markers, it is often defined to move the marking pin out of the way so that you can easily remove or secure the parts being marked. If the pattern is designed to seek home after printing, see above. The marking head will move home first, then part. Pre-positioning may be used to set the marking head in place for printing. The pre-position feature places the impact pin over the anchor point of the first field in the currently loaded pattern. Print order. Objects in the pattern are marked in the order that they are created, i.e., first created, first printed. The marking head will mark the first object in the pattern list, then move to wherever the next object is to be marked, and so on. Therefore, you should expect the marking head to move from any location in the marking window to any other location at any time during the marking cycle. Operation overview. 2 to 8. 2.3 Using the system software. This section describes basic procedures for operating the system software. It introduces you to the main operating display. It explains how to enter data and execute commands. It also explains special keyboard features you can use while operating the marking system. You should be familiar with these procedures and comfortable with operating the software before using the marker. Complete information on using the system software is provided in Chapter 3 Operator Features and in Chapter 4 Supervisor Features. 2.3.1 Starting the system. When the controller is turned on, the keyboard will briefly display the startup screen. This screen displays information about the system software. It's important to note the item number and version number in case you need to contact Telesis customer support with questions. Number $% and asterisk. Startup screen. After a brief delay, the keyboard will display the operator's main screen. Plus, minus, 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 /010, 221 2223 and 42 and 5. Operator's main screen. The top line shows the operating mode, operator or supervisor, the current status of the marker, offline or online, the name of the currently loaded pattern, if no pattern is loaded, and the number of fields in the pattern 00. If no pattern is loaded, the next lines show the contents of the first two fields of the pattern. The bottom line lists available commands and the associated function keys F1, F4 that execute them. TMP 4100 series/400 operation, 2 to 9. 2.3.2 Using the keyboard. The keyboard is your interface to the system software. It allows you to make selections, enter data, execute commands, start/abort print cycles, and jog the marker. The keyboard is similar to other computer keyboards. However, there are special control keys and special editing keys that apply specifically to operating the marking system. See Figure 2 to 2. Figure 2 to 2. The operator keyboard. Special control keys. Function and function keys function 1 through function 8 are assigned various commands, depending on the current screen displayed. Pressing a function key executes the associated command. Next displays the next page of the current screen if more than one page is available. If the cursor is positioned within a list, pressing the next key will scroll down through the list. Previous displays the previous page of the current screen if more than one page is available. If the cursor is positioned within a list, pressing the previous key will scroll up through the list. Print initiates a print cycle. The marker must be online and a pattern must be loaded to print. Abort stops a print cycle in progress and places the marker offline. Jog enables the jog feature and displays the jog screen. Refer to chapter 3 for details. When the jog feature is enabled, the arrow keys jog the marker through its range of motion. ESC exits the current screen and returns to the previous screen. Help displays helpful information about the currently displayed screen. Press the next/previous keys to page through the help screens. Press the ESC key to exit the help screen. Operation overview, 2 to 10. Special editing keys. Tab moves the cursor around the screen from field to field or from parameter to parameter. Allows you to position the cursor on the item you want to select or edit. Hold the shift key down and press tab to move the cursor backward. Moves the cursor to the next/previous field, parameter, or selection. If the cursor is positioned within a text box enclosed in brackets, moves the cursor horizontally within the box. Allows you to select the character position within the text box where you want to edit, insert, or delete text. Note: if the cursor is positioned on the first character in a text box, all characters will be deleted from the text box when you begin typing new characters. Cancel the current edit or selection. Enter normally used to accept enter data in the currently selected field and proceed to the next field. Parameters values enclosed in braces do not accept typed input but may still be edited. When the cursor is positioned on one of these parameters, pressing the enter key will toggle through the available choices. Ins toggles the keyboard between insert and overstrike mode. In overstrike mode, existing characters are replaced by the new characters as you type. In insert mode, the new characters will be inserted at the cursor location, pushing existing characters to the right as you type. Del deletes the character at the cursor location. Characters right of the cursor will shift to the left as you delete. BS pressing the backspace key will delete the character to the left of the cursor as the cursor moves to the left. If the keyboard is in insert mode, all characters to the right of cursor will move left to fill the space. When in overstrike mode, all characters to the right of the cursor will remain in place, while the deleted characters are replaced by spaces. The control key may be used with other keys to execute specific actions. These features are described in chapters 3 and 4, where used. Caps lock the